So now in this video we have a passive buzzer. That's what's creating the clicking. But we can increase the speed of the clicking by lowering the resistance right there. And I know that's probably getting annoying. I'll try to wrap this up. Looks like 20 milliamps of current is enough, but if you ever see CC on the power supply, raise the maximum current that it can provide. So now, passive buzzers depend on a changing current, one direction and then the other to make their clicks. The 555 doesn't necessarily alternate current, but if you add a capacitor in series, it does a couple things. First, it lets current change direction through the passive buzzer because one end is to ground. When the output's high, the capacitor charges, it clicks, and then when it goes back low, capacitor discharges and the passive buzzer clicks. And I couldn't remember if the passive buzzer had the epoxy in the bottom or not, and it looks like it does not. It is polarized. There's a plus up there. Put that towards the more positive side of the circuit, and I couldn't find the normal buzzers I use, so I just grabbed this one from a different kit, and so I couldn't verify that the one with the epoxy is active. If it's active, you can just apply a voltage across it, I think up to 5 volts, and then it will buzz, just on its own. This one will not buzz. I applied power, I got a short circuit, the power supply turned off, and you can hear clicking when I use it in the circuit, so I'm certain that is a passive buzzer because that's what they do. But yeah, in any case, we'll get back to this. Has to alternate directions, and so that's what this setup does here. 10 microfarad may not be the best capacitor value. Maybe you need a little bit more. Maybe even a little bit smaller will be perfectly fine. So now, since the passive buzzer needs, a steady stream of alternating current in some way or the other, we have the 555 timer that's going to keep bouncing the output high and low if it is wired in astable mode, which we have here. So I have a 220 ohm resistor coming to that jumper and pin 7 right there. So when the output is high, pin 7 is not doing anything. It's an off switch. We got current flowing through a 220 ohm resistor. We need to make sure we always have current limited. So 220 is about the minimum we want with 5 volts. Always remember that. But then we come to the Trimpot. So that end is not connected to anything, but we could tie it together to the wiper. That way, if the wiper fails, we'll just get the full resistance coming through. And so we can make a connection there. But otherwise, if you set the wiper halfway, the current's gonna go through half the resistance and then go around the rest of the Trimpot if it's connected there. So just be aware of that. You'll see that from time to time. It'll be connected there. But the only resistance that matters, as long as the wiper works, is where the wiper is connected, because then it goes around. So we come there, and if I turn the arrow away from where this jumper is, we got the full resistance all the way. Now we got like half, and now we got no resistance. So you're limited to the size capacitor that you use here. Maybe even 1,000 microfarad might be okay. But you do have a short circuit if you do 0 ohms of resistance when it discharges. So be aware of that. But probably that's fine with 10 microfarad. Again, we could add a little bit of resistance there to eliminate that. We'll always have a little bit of resistance there. But yeah, that's basically how it works. Just as a review, when you got a 555 timer in astable mode, pin 6 and pin 2 are looking at the voltage of the capacitor. When you first apply power, then it's 0 volts, and pin number 2 sees that. It sees that it's a low input, less than 1/3 of the supply voltage. And that allows the capacitor to charge through whatever resistance it has to charge to. Pin 6 is waiting for 2/3 of the supply voltage or more. So it gets up to 2/3 of the supply voltage. It sets the output low, connects to ground, and also pin 7 connects to ground. Before it wasn't doing anything, it connects to ground. And then the capacitor can discharge until, again, it gets to 1/3 or less of the supply voltage. And so it's going to keep bouncing back and forth. Takes a little bit longer to charge, so the output's going to be high a little bit longer than what it discharges. Maybe even a lot longer if, like when you set it down to 0. But in case, it's going quick enough where we can get a buzz when we set this to 0, even though it's high for a long period of time, and it goes low practically instantly, relatively long time. And when it comes to these dual inline package integrated circuits, you usually got 1 or 2 dimples that go to the top, and then top left is pin number 1. You work your way down. We only got 4 on this side, but then when you get to the bottom, you jump across and work your way up with the numbering. But yeah, we got to power it. Ground is the negative supply there, and then VCC is the positive supply. That's what VCC means. You may see like V plus or whatever. There's different ways to indicate it. Pin 4 is the reset pin. We don't want it to do anything. It's waiting for close to 0 volts, and then it holds the output low no matter what if it sees 0 volts. So we don't want it to ever do that. We just put it directly to the positive supply. You could also use a resistor if you want to. But in any case, putting it to the positive supply, make sure it doesn't do anything. And then of course the output is pin 3 right there, and these two are monitoring the same voltage, so we have a jumper that comes across. Whatever voltage we give pin 2, pin 6 will see it as well, and it's also a charging path right there for the capacitor and discharging in this particular setup right there. So be aware of that. And if you want it to go faster again, simplest thing you can do is use a smaller value capacitor right there. That's kind of what we're limited to in this video. But if we wanted to take longer, we could, increase the value of the Trimpot and or that resistor even. And also we could just use a larger value capacitor to make it take longer. There's all kinds of ways to modify this. None of them are wrong or anything. Just whatever works for whatever you want. Hopefully that makes sense. So in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.